Hello viewers and my dear students. Welcome to session 4 on one-dimensional problem analysis. Here I am showing a demo on one-dimensional bar analysis. We have already completed 3 sessions on this and this is the 4th session. We are showing a demo using Ansys. And as you see here, at the end of session 3, we have completed the meshing part. And I showed you earlier, see here, list elements, the meshing. See here, 2 elements have been created. That means meshing has been over. And also assign the properties that this is steel and this is aluminum and all that I have already shown you in the previous session. Okay, see here, all those things. These even key points also, you can see the coordinates. 1 is 00, 2 is 600, 3 is 1100. In that way, whatever you want. List elements, create list lines means, okay, okay, this line for that is create lines, that is what you have created, that also will be listed. Okay, that is 1 to 2 and 2 to 3 we have created 2 lines, line number 1, line number 2, 1 to 2 and 2 to 3 we have created lines. In that way we have created, we have meshed also. Okay, now we have to go to solution phase where we have to load. That means this under meshing only I have said the first line is aluminum. Okay, actually if you see plot lines, okay, this plot lines means actually is this here. This is line number 1, line number 2. This is I have already assigned this is steel. I have already assigned this is aluminum. Okay, this already I have done. Plot elements means it will go to this. Okay, now everything we have done properly till now. Now we have to go to the solution phase. So in the solution phase, now you go for loads, define loads, apply structural displacement on key points. You say this point anyway is fixed. No, first key point you take, say okay, and you see you arrest all degrees of freedom. Okay, just say okay. Okay, all degrees of freedom is arrested here. Okay, that you do. Now you know very well, in this problem, as you see here, there are no other loads except, if you see this problem here, there is a load of 500 Newton applied here. Correct? No? 500 Newton in positive direction. Okay, that is why we'll go now, we'll go for force moment on key points or nodes, whatever is that you take. On key points you take, just click on this point and say okay. And fx, you see here, x is this, positive x is this, negative x is this, positive y is this, negative y is this. Okay, now fx, it is 500 newtons, correct? No? It is 500 newtons. 500 newtons you give positive. If it is negative means it will give in the other direction. It will give in this direction. Now 500 you say okay. You see here. Can you observe? See here. See here. Plot. Multi-plot. If you see, yes, you see here. The load has been given in this direction, positive. Don't make minus 500. Minus 500 means this way. The entire answers will go wrong. Okay, it should be this way. Okay, plot elements. You just do it this way. It is over. Okay, the load is here. Okay, now once you do everything, okay, now you go for solution. Okay, solve. Current load step you apply. Current load step you see. Just say okay. Current load step you say. Just say okay. Now once you do this current load step and okay, you should get a message solution is done. This message you have to get. If you don't get this, it is clear that you have gone wrong somewhere. Immediately what you have to do is you do that resume DB. That means you go to the stage where you just messed up. Okay, and you start repairing it. Okay, immediately you do resume DB. From there you start correcting. Okay, this is the thing, you have solved it. Okay. Okay, now you see here, once you do this, look here, Now, up till here, it is called the solution phase. That is, applying the loads and solving is a solution phase. Okay. Now we'll go to the third phase, which is called general post process, where we view the results. Where we view the results. Viewing the results. Okay. General post process, you go. Okay. Now you have to see the results carefully. Now you see here. Now you know very well. Since the problem has here 500 newtons means, okay, there is only one support here. Reaction solution at node 1 should be 500 newtons in the other direction. See here, list results. Okay. Reaction solution, if you give, okay, you see here, all items you say. List results, reaction solution, all items you say. Okay, if you do, at node 1, it is minus 500. Is it okay? It is perfect. Because at node 1 is this. Node 1 is this. And it is acting in the opposite direction. Because it has to balance. No. This is acting in this direction. Here the reaction solution at the support will be in the other direction, minus 500. Fx is minus 500. It is proper here. That means this is over. Now, actually as per the problem, you have to find displacements. Okay. Displacements you have to find. Okay. You see here, nodal solution you go. DYF solution you go. Displacement vector sum you go. And just say okay. Now you see here, displacement vector sum if you do, you see here, at node 1 anyway it is 0, 0, 0. At node 2, 0.1667 into 10 to the power of minus 2, which is same as what you have got by our theoretical method. You see here at node 2, you see here, I'll just see, which is node 2 also, plot controls, okay, numbering. If you do node numbers, no, I'll make it on, you see here. I'll make it on, okay. And you see here, this is node number 1, this is node number 2, this is node number 3. At node 2, it is 0.1667 into 10 to the power of minus 2. Okay, it is same as what you got by theoretical methods. Okay, if you see here, theoretically, you determine, you see here 0.0016. And next is 0.0073. In that way, this is 0.0016 is verified. In the same way you see here, this is 0.769, 761 into 10 to the power of minus 2. That is also, see here, this is 0.0073, which is almost correct. Okay. In that way, that is also verified. Okay. That means the displacement at 2 and displacement at 3 have verified. That means this you see, by theoretical method also you got this. Theoretical method also you got this. At node that is displacement at node 2 is so much. The node 3 is so much, that is 0.7619 into 10 to the power of minus 2. And at node 2, 0.16667 into 10 to the power of minus 2, which we have done it theoretically also, you are getting the same results. In that way we have verified. See here, now after this, you have to determine that is member forces and member stresses. For that, you don't get in the general post process, you don't have any command to get the things directly. For that, what you do is, you see here, what you do is, you go for element table. Define table you do. Add you do. Okay, I have told you earlier, okay, for getting axial stresses, you just say LS1, 2 or LS1. That is enough for element 1. Okay. But since we are defined separately, you get axial stress for both. That is LS1 you put to get the axial stress. This I have told you under session 2 only. Please go through that and recollect. LS1 you do. LS will represent axial stresses. SXX. I have told you already. This you say apply. Okay. LS, see LS1. That will give the axial stress. In the same way, go by sequence number, you go again, and SMISC 1 you give. SMISC 1 will give you what exactly is the member force in every element. Here 2 elements. In that way, this also you do. That is LS1 and SMISC 1. You do, this is LS1 and SMISC 1, and status should be current. Be careful, okay? I will tell you about this later on. Status should be current. Okay. Then say close. Okay. Now this you have done it. Carefully you see. Okay, carefully you see, that means this you have done. Now what you do is, under list results, element table data is there. LS1 and SMISC1, you just see, these two you highlight. LS1 will give you the results about axial stress, and SMISC1 will give you results about member forces. Just see, okay. See here, beautifully you have got the same thing. Element 1, you have already determined, okay, that is LS1, axial stress is 0.5556, that is exactly the same thing what I got. And element 2, axial stress is 0.8333, it is same. And as you know, the member force, since this member force for element 1 and element 2, both it is 500 only. Because as you know very well here, once you have an element like this, that is loading is this way, 500, here also it should be 500, here also it should be 500. In that way, in both the elements, the element, since it is 500, it is subject to axial load of 500, even here it should be 500 newtons, here it should be 500. The reaction only will be 500 in the opposite direction. In that way, we have verified this also correctly. Okay, did you follow? See here, the LS1 and SMISC1 also you got. So you see here, these things I have told you, most of the things we have done already. Okay, now you see here, now what exactly you want is, see here, what exactly we have found out the thing is, under list results, first thing, reaction solution, all items. You see here, this, you can take the printout. Okay, plot controls, actually you can write meta file, stand in invert white and black and all that, whatever is that. Otherwise also, you copy down the same thing, paste it in Word format, and this is the answer, one of the very important answers for the examiner. This you can save it and paste it in Word. Okay, this is one thing. And then you go for element table data also, LS1 and SMISC1. This also is another very important thing. This also you paste it, that is also, this also you can copy it and paste it in the Word. This also is a very important answer for the examiner. Okay, that means this axial stresses in the two elements, member forces you have determined, and also I have told you the important thing here is, under nodal solution and DOF solution, displacement vector sum, this also is very, very important. Whatever we have done, at node 1, 0, 0. Okay, at node 2, this is the answer, 0.1667 into 10 to the power of minus 2. What we have got theoretically. At node 3, 0.76190 into 10 to the power of minus 2. What you have got theoretically. This also you copy, or that is you make it in a tabular column. Okay, this also you have to show it to the examiner. In that way, we have got all the solutions, whatever we have done it by theoretical methods. Okay, now as you see here, some of the things what you have to clearly know here is, list you see here, list loads, forces if you see, on all key points or all nodes if you see, you can see here, at key point 3, the force is 500, correct? No? You can see whether you, sometimes you get a doubt, all of a sudden, whether you applied correctly or not, you can see everything. List key point, you just see coordinates, you can get 0, 600, 1400 in that way. These things I'll explain clearly in the next session also. Okay, now we have completed this problem and some more elementary things have to be told. This I'll do it in the next session. This is the end of session 4. Thank you very much for viewing. Thanks friends. Thank you.